welcome. Yeah, so this is the last and therefore the third of 3 videos, all on the nth roots of complex numbers. In the first video, we answered the question, what are the 3 cube roots of 8i? And we also, there in that first video, came up with this really nice general formula that allows us to find the nth root of any complex number z, right? And we demonstrated how to use that formula there in that first video, but we additionally used that formula in the second video, where the focus in the second video was answering the question, what are the 3 cube roots of 1? Yes, the number 1 has 3 cube roots. And the focus here and this final of these 3 videos, as you can see, is answering the 2 questions, what are the 2 square roots of I and what are the 3 cube roots of I? Yeah? Okay, cool. So it is of great benefit to you in understanding this video first and foremost, but also maybe in many other ways, that you, before watching this video, watch the aforementioned 2 videos. But if you choose to not do so, enter at your own risk. And so here it goes. Now, the formula that we came up with in the first video was this, right? Which said that the nth root of any complex number z, which is denoted differently as this. In other words, this too is saying the nth root of z, just like this is saying that. But yeah, the nth root of z, it turns out, is equal to this here, where k goes from 0 to 1, then to 2, all the way to n minus 1. Yeah? Okay, now, we've already used this giant formula before. It's not really that big. But yeah, we've used this formula before in the first 2 videos, so I shouldn't have to handhold you on how to use it. So let's get right to it. Why don't we use it to figure out what the square root of I are, what the 2 square roots of I are, right? And by the way, as I said, because I already have a different video dedicated to showing you what the 2 square roots of I are, and there in that video we do it using algebra, I'll just tell you what we discovered then, which is that the 2 square roots of I are root 2 over 2 plus I root 2 over 2, and then negative root 2 over 2 minus I root 2 over 2. These are the kind of things that are in my head as I'm like boarding a bus or like going into the train and so on. Like very impressive things that no one cares about. No, actually, these are of great consequence, supposedly, knowing these things. Okay, anyway, we see that based on the formula, we have to do k equals 0 and then k equals 1. But again, we've used this formula before in the previous 2 videos, so no shock. Right? Okay, now this theta here is the principal theta for the complex number I, in other words, this complex number z that we're taking the nth root of, when it's expressed in polar form. So when I is expressed in polar form, that is in r cis theta form, I is equal to 1 cis 90, right? Yeah, so that should be pretty obvious, and I shouldn't have to write it down, so I'm saying I for or theta for I in r cis theta form is 90. So there we are. Okay, and here I've done some simplifying, which is 360 cut in half is 180, and so there that is. But still, k is gonna be first 0 and then 1. But before, because we already have that as a reminder, before we do anything else, let's simplify here. That 90 over 2 there is a 45. So we see that the square root of I is given by cis 45 plus 180k, where k is first 0 and then 1. So we're going to get 2 answers out of this by choosing k equals 0 and then k equals 1. So let's do that. When k is equal to 0, we're going to get that the square root of I, which this time in this third of the 3 videos I'm being a bit more careful about, right? Like, so in the previous 2 videos I called the square root of whatever complex number we're seeking, or the cube root, right, whatever the case may be, I called it z, right? But technically this should be a different name than this, because, well, in this writing, the nth root of z here is the complex number that we're taking the nth root of. So the nth roots should have a different denotation, like w and like x or anything but z, right? Okay, so that note, but like it was not really a mistake to call the roots also z, because it's implicit that like if we call this guy here a z instead of a w, then we're not talking about the same z as this guy, right? Clearly this time we're talking about the roots. But yeah, like I'm saying, the nth root of z, we can call that w, and whatever w is, well, it's first for the square root of I, it's first this. And so, you know, like this just says cis 45, and that's cosine 45 plus I times sine 45. As I said, that comes out to root 2 over 2 plus I root 2 over 2, and we've already seen this result in a different video, all dedicated to simply answering the question, what is the square root of I? Or rather, what are the two square roots of I? Yeah, so here's one of them. And so anticlimactically, we find the second by allowing k here to be 2 now. Yeah, so when we do that, what we're going to, well, no, sorry, we let k equal 1, because we only had k equals 0, and then now k equals 1. My bad, guys. Okay, so when k is equal to 1, but you knew that. This is what we're going to get, and this time we're going to get the other root of I that I spoke of, and that's minus root 2 over 2 minus I root 2 over 2. So there that is. So these are the two square roots of I. We don't need anything else but retaining the two square roots of I. So let's get rid of everything else and remind ourselves that these are the two square roots of I. So now let's work on the cube root of I. This is sort of like a summary lesson, because, well, we beat these ideas to death in the previous two videos, so none of these should be unfamiliar, and this is just offering you a second way to get to the square root of I, and in turn show you how easy it is if you use this formula to find the cube root of I, and it's just as easy as it was to find the square root of I. And additionally, as I said, I'm going to once more talk about the geometry of these nth roots of complex numbers, and so it's basically reinforcing lessons you've already had in this video. So, like, yeah, we're still talking about I and our cis theta form, so theta for I is still 90, and this time we're doing cube root, so n is 3 this time, right? Okay, cool. But otherwise, you know, business as usual, and of course k this time is going to go to 0, 1, and 2, because, well, k is going to end at n minus 1, so if n is 3, no wonder that k ends at 2, right? So here, beyond simplifying this 90 over 3 into a 30, all we're going to do is choose k to be 0, and then 1, and then 2. That's going to spit out 3 different complex numbers, and those are the 3 cube roots of I. Yeah? Okay, so you know what to expect. As I said, we elect k to be 0, and first we get this, and that's this in rectangular form, and this in long version of the polar form, the r cis theta form. This is a longer version. This says cis theta, right? And the r obviously is 1, because we're talking about the cube root of I, where the modulus of I to start is 1, and therefore its cube root is also going to have a modulus of 1. But in any case, if you express it in rectangular form, the first cube root of I is going to be this guy. And so then the next cube root of I, no surprise, is going to come by setting k equal to 1, and that is going to look like this. And then finally, the third cube root of I, and this should come as no surprise, is going to be, well, letting k equal 2, but it should be no surprise for a different reason, and that's because we know that I cubed is negative I. So negative I cubed is going to be I, and therefore we're not surprised that one of the cube roots of I is negative I, right? Okay, cool. I probably said that too fast, but, like, you know, like it was intended for fast catchers, that last part, huh? Okay. So we've got the 2 square roots of I right here. We've got the 3 cube roots of I right here, 1, 2, 3. And so all that's left from my promise is for us to look at the geometry, right? And I already said this in the previous 2 videos, but complex numbers, if you visualize them, for nth roots, so for these guys, for cube roots and square roots, have a really nice visual to them. They have a really nice geometry about them. So, like, in polar form, as I already said in the previous 2 videos, in r cis theta form, a complex number is completely determined by r and theta. And so like these two guys in r cis theta form, they're specified by 1 cis 45 and 1 cis 225. But look at where they're at, right? Because because there's 360 degrees in a circle, and we're doing square roots, so n is 2 for square roots. We take 360 and divide it by n, and so 360 divided by 2. So once you figure out where one of them is, 360 divided by 2 is 180. To find the other square root, you just go 180, and you will be able to find the other square root. Technically, in the real imaginary axes, this circle and these lines are not there. I'm just helping you visualize the complex numbers. The complex numbers would actually be just a dot here and a dot here. A dot here for this one, and then a dot here for this one, right? But in any case, as I said, their R value and their angle is completely deterministic of them, and this one is this one, and this one is this one. And so once you figure out where one of them is, then you could just take 360 and divide by n, where n is whatever is involved in the nth root, and whatever 360 divided by n is, you add that amount to the angle measure of the first one that you found, and you'll be able to get to the second one. Yeah? Okay, cool. Yeah, that's what I just said. And you've already seen this before, and so this is no surprise. That's what I just said. It's also no surprise. Yeah. If I was listening to me. Okay, I would know that. Okay, so to conclude, the cube roots also have the same nice geometry like the square roots had, only like there are 3 of them this time. So the first of them is right here, a dot right here, and so this time we do 360 divided by 3, which is 120. And so once we get to the first one, we just add 120 to this degree measure to get to the next one, and then 120 more to this one is going to get us to the third one. So the 3 of them are, as you see them, they are 1 cis 30, 1 cis 150, and 1 cis 270. And yes, I just said cis, cosine theta plus I times sine, and then theta. So I guess it should be like cis theta. But anyway, if you don't know what cis is and you want to know what all that business is, then I have lots of videos introducing complex numbers in polar form. So watch those videos. Yeah, but besides that, I hope you've enjoyed all 3 videos, and keep watching. Take care.